Okay, here we go. I'm hoping if you're here on Friday, you can answer all these questions. Maybe the graph might be a little shaky, but at least answer all these questions here. So let's do that. According to this equation here, -2 cosine x minus 4, what's my amplitude? Amplitude should be +2. You always take the absolute value of whatever number is out in front, in this case, -2. Amplitude, always positive. Where am I shifting? Up, down, and how many? Down 4. -4 tells me I'm going down 4. Plus would tell me I'm going up. So down 4 units. I'm going to skip around now. What's the period here? 2 pi, and that's been the same until today. I'm plotting a point at every 90 degrees. I'm plotting a point, aka pi over 2. That will change today. All right, hopefully we have this ability to find out what my maximum and my minimum value is just by looking at the equation. I should not have to graph. So here's what I'm going to ask you guys first. Before I shifted it down 4, all right, before I shifted it down 4, what was my min and my max? Before the shift. What do you got for me? Crickets. -2 and 2. You get that from your amplitude. Now you shifted it down 4. So subtract 4 from your min and max. What is my new minimum now? -2 minus 4. -6 for my new minimum. And what about my new maximum? -2. If you know those two, you know the range now. The range goes from what to what? All right, we can go -2. Oh, sorry, not negative. I got to put the smaller one first. -6 less than or equal to y less than or equal to -2. Or as I discussed all last week, you can also do the brackets for the range. And finally, what's my midline equation? What line splits the minimum and maximum right in half? And this is another name for the shift. What was my shift? -4, but I'm not going to accept that because it's a line. It's a horizontal line. Y equals -4. Okay, just to save time, can we just graph it in the positive direction from 0 to 2 pi, please? My suggestion on yes. Yep. That's the higher one, right? Okay. I know it's negative, so that's kind of freaky, but it is the maximum value. All right, on Friday, I suggested to you, and you didn't have to take it if you didn't want to. My suggestion, plot the points before you shifted. So I'm going to plot the points for -2 cosine x first. I'm not going to graph it. I just want to plot the points so I can move them. So here's my question to you guys that were here on Friday, or anybody, really. Cosine, where does it usually start? At the max. But tell me something about this graph. You got a negative out in front. So it's not going to start at its max at 2. It's actually going to start flipping it, start at its minimum of -2. And again, I'm just plotting the point. All right, where's cosine's next critical value? 0, right? And that -2 does not, outside here, does not affect that 0. So usually it goes max, 0, then it goes to its minimum, but the negative says, hey, you better flip that beast and go up to 2. And then it goes where? Keep going now. I got 0. I got max, 0, min, 0. That's not going to get affected. And then where's cosine usually end? Usually at the max, but I'm flipping it over to the minimum. What do I want to do with all these points now? Now you're ready to shift. Take all these points and move them down 4 units. So count 4 units down from each point. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then down 4 again. So this is my final curve for this one. Hey, and everything should match up, right? Is my high point -2? Darn right it is. And is my low point -6? Yes, it is. So those should all match up. Is there anything on the graphs? Because today, really, I'm going to take a totally different turn with this, because these are not going to be all pi over 2 pi, 3 pi over 2 anymore on the x-axis. Anything there? Because I'm doing 2 more homework problems with you still. I'm not done yet. I'm not confident yet. We okay here? Okay. Next one I want to do with you is number 3. Yes, number 3. I have graphed cosine for you. It's got a certain amplitude, and I shifted it a certain number of units. I want you to find that amplitude and the shift just based on the graph I've given you. On the front of your packet, you should have 2 formulas I had given you on Friday how to find those values. How do you find that A value, the amplitude? How did we find it? We took the maximum and minimum and did what with them? Subtracted them and divided it by 2. That's how I find the amplitude or the A value out in front. All right, guys, look at the points I gave you. What is the highest Y value, the maximum value? 9. Now be careful here. Be careful. What's your minimum? So it's going to be 9 minus a -5. Yep, not 9 minus 5, 9 minus the -5. So the A value out in front should be 14 divided by 2, 7. And then how do you find the shift? Very similar formula, but instead of subtracting the max and the min, I'm going to add the 2 together. So now 9 plus -5 divided by 2. How many units did I shift this? What's that? 4 divided by 2? 2 units. I shifted it 2 units. And again, I can't stress this enough. This should all, I know you're just finding numbers, but make sure they match the graph. Here's why. Before I shifted, my A value was 7, meaning it's going to go up to what? Before I shifted it, if that number's 7, it's going to go up to 7. And this tells me how many units did I shift it. So I'm at 7. I shifted it up 2. Where should I be? Boom. Okay, my high point should be 9 now, so it should match the graph. We okay there? All right, last one I want to do with you is 6. When you graph y equals 14, stop. What is y equals 14? Is that diagonal, horizontal, vertical? What type of line is y equals 14 if I had you actually graph it? That's going to be a horizontal line going through 14. So just to get a visual of what it looks like for you, here you go. That's y equals 14, that line right there. Okay, which one of these graphs would not intersect this? All right, and all this comes down to is the minimum and maximum. Can you find the minimum and maximum for all 4 choices? I hope at this point. Let's take example 1. I always like to talk pre-shift, before you shift here. So before I shift the 9, what's my minimum and maximum? 5 and -5, and then you guys add the 9 on. All right, so here you go. What's my minimum for choice 1? 4, and my max? Okay, so think about this. It's going to go up to 14. Will that line intersect it? Yeah, just barely on that maximum mode, it's going to intersect. Everyone agree it's going to intersect? Just once, but it'll intersect. All right, let's go to 2. And I know I should be asking individually, you guys, but we just don't have the time here today. Before I shift it 15 units, what's my min and max? -2 and 2. Add 15 now. Go up 15. New minimum. 13, new maximum. Okay, will that graph hit? Will it hit? Well, some of you are shaking your head no. Why not? Hey, 13, watch, ready? 13, 17. Here's the graph. It's going to hit because 14's in between there. All right, it's going to hit. All right, what about choice 3 now? Thanks, guys. Thank you. Thank you. Thanks for your help, guys. Thank you. Okay, number 3. Before I shifted it, what am I shifting here? 10 units. What was the min and max? -6 and 6. Shift it 10. Now it's going to be 4 and 14 going to go through there? Yep. Okay, so why? I know by process of elimination it's choice 4, but why? Okay, before you shifted it 20 units. -3 and 3. Okay, ready? Watch. Add 20. It'll be now your minimum 17 and 23. Why wouldn't 14 hit? Yeah, here's your 14. Here's my darn graph way up here. All right, here's my graph way up here. It's not going to hit because 17 is my minimum. All right? How are we with this right now? I'm planning on Wednesday quizzing. All right, not just on this stuff, but what we do today too. Q4, yes. My grades aren't due until next week. Q1, sorry. I don't know. I'm just fired up right now. It was choice 4 that was on my mind. No excuse. Q1, yes. So we'll go on Q1. All right. Anything else from you guys? Okay, before we start, make sure there's still some on some other desks here. You and your partner should have 2 colored pencils between you. You and your partner, 2 colored pencils. There's some here. Make sure you got 2 here. I got 2 more. 2 more. Two more. Anybody else? 2 more colored pencils. Anybody else need them? Make sure you have 2 between you and your partner. You can have both. Okay, I was going to hold on to it. All right. We know the effect of having a number out in front. That shows me how high and how low it goes. What about today when I put a number in between the cosine and the x? How's that going to affect the graph? All right. So that's our deal today. So what I did first on your graph, what I did first is I graphed for you y equals 3 cosine x. And it looks pretty good, I know. It goes up to 3 and down to -3. Checks all the boxes, right? Where does cosine start? At its max. So it starts at 3. Then it goes where? 0. To the 0, to the minimum, 0, back to the max. So it looks pretty good. All right. Now, here's what I'm going to have you do. And I know it says using your calculator, but I'm just going to give you the points because I don't want you to become dependent on the calculator. All right. 3 cosine 2x. What's the main difference between the two here? I got this darn 2 in here. How will that affect the graph? Here we go. All I want you to do is we're just going to graph from 0 to 2 pi for time's sake. Okay. Here's your first point. It's still at its max. Okay, we are graphing this one now. I'm just giving you the points where they are instead of us looking them up on the calculator. Halfway between 0 and pi over 2, it's at 0. Halfway between. At pi over 2, it reaches its minimum, which it would be. What's still the minimum here? -3 at pi over 2. Halfway in between pi over 2 and pi, it goes back to 0. And at pi, it returns back to the beginning at its maximum. And let's do that one more time because you know the cosine curve and sine curve is going to start repeating. So halfway in between pi and 3 pi over 2, you're back at 0. At 3 pi over 2, you hit the minimum of negative 3. Back at 0, halfway in between 3 pi over 2 and 2 pi. And then, yes, we end up at 3 once again. So take one of your colored pencils right now, and please graph that in. And make sure you label it, please. Make sure you label it so you know, because we're going to put on a third one here in a second. Can you and your partner please quickly answer letter B? How many full cycles of cosine do you see now between 0 and 2 pi? How many of your cosine graphs do you see from 0 to 2 pi? Because you do not see 1 anymore. Okay, how many cosine curves do you see from 0 to 2 pi? Just from 0 to 2 pi, how many cosine curves are there? No.
It's 2.
This, okay, hey. This is a full this is what cosine looks like.
It can't be the other way.
How many of these do we see here? Ready?
Yeah, but if it were negative.
1, 2. What do you mean negative? Everyone agree? I see 2 of these. Can we all agree? Okay, so I see 2 cycles. Have I seen that 2 before?
Yeah.
Where? In the equation? That you guys told me at the beginning before I told you how to graph it, that was the main difference, was the 2, right? So, conveniently I saw 2 of them. All right, let's see if that pattern continues. Now we're going to graph a third and final one, but now I'm going to put 1/2 there instead of a 2. Here's what this graph looks like. Everyone ready? The first point is the maximum still at 3. At pi, it's 0. At pi, it's 0. I don't know what the value is at pi over 2. It doesn't matter. But I know at pi, it's 0. And ready? At 2 pi, it goes to its minimum, negative 3. No, it is not a line. It is a cosine curve. It's not a line. Don't do a straight edge. It's a curve. Grab your other colored pencil that you have not used from your partner and graph in the curve. And make sure you label it y equals 3 cosine 1/2 x. Yeah. All right. Discuss real quickly. How many cosine curves do you see here? I just see half of one, right? I just see the first half of the cosine curve. Everyone agree? All right, so I see half a cycle here. Did that half come up anywhere? In the equation, yep. So this new number here in between the cosine and the x is going to tell me how many curves I'm going to see. Is everyone in agreement? Okay, I actually want to give a name to that number. I don't want to call it the number in between cosine and x. I want to actually give a name to that number. And that name now is called the frequency. Okay, with the B value. You have an A value that's outside. You have a C value, which is the shift. And now we have a B value in between that's going to be called our frequency. All right, that's how many we're going to see. All right, you and your partner, buckle up. That first graph I gave you, 3 cosine x. What was the b value? What's that? Oh, the very first one I did for you. That was already there. It was 1. All right, let's see if you can answer this now. What is the period of that one? How long did it take on the x-axis to make that original one? 2 pi. Perfect. So when my b value was 1, the period was 2 pi. Moving along. The second one you guys graphed. 3 cosine 2x. What was the b value or the frequency here? 2. And the period changed. Whoa, not bad. How long did it take to make one full curve? Right here, from 0 to pi. Yes, from 0 to pi. Nice job. Let's see how good we are on the next one. What was the frequency on the last one you graphed? 1/2. And you guys you don't see a full curve, do you? But, if I continued this out, how long would it take for me to see the entire curve if I saw half of it at 2 pi? 4 pi. All right? What's that?
Because it's only half going to 2 pi, so where's the other half?
It's going to take another 2 pi to get out to the rest of it, right? Okay, there is a relationship now. There is a relationship. As the frequency increases, what happens to the period? Decreases. And as the frequency decreases, what happened to the period? 1 to 1/2 decreased, right? What happened to the period? 2 pi to 4 pi. Increased. So here's what we're saying. As one goes up, the other goes down. Okay? As one goes up. Oh, an inverse relation. Nice job. Nice job. Did you just read that on the next page? Or? Okay. Yes. But here's the thing, though. I'm not going to ask you to graph every time and tell me the period. I want you to be able to look at these equations and say, that's the period, 4 pi pi, without having the graph. So how the heck do we do that? I got a formula for you. Simple formula to find period. Here's how you do it. The period of any sine or cosine graph can be found by taking 2 pi, always 2 pi, and dividing it by b. And if you don't believe me, stay on the page you're on. Just let me go back a page. Maybe. Everyone ready? Let's take this one here. What was your frequency? That's the period. Stay with me. What was the frequency for the second one? What cancels out? Oh boy, for this one. What's your frequency? How do you deal with that? Oh boy, yeah, your little keep change, somersault, cartwheel, whatever, all right? Yep. 2 pi times, what do you multiply that by? And what's that going to be? Okay. So if you want to find the period, just given the equation only, I'm going to take 2 pi and divide it by whatever heck that b value is. All right? Okay, let's do that then. No more graphing. No more graphing. I want it just by the equation only. Find the period. So you guys have a new formula. It's 2 pi over b. What number is in place of the b here? 6 or 4? 4. 6 is your amplitude. So I divide it by 4. And all I need you to do is simplify, if possible. So what's the period here? Pi over 2. And I love that you're able to find it, but I also need a little bit of understanding what that means. That means if I were asking you guys to graph this, when would you see your first sine curve? At pi over 2. Okay, so that thing, think about your sine curve on your paper right now. That thing would be scrunched, wouldn't it? If I'm going to see 1 from 0 to pi over 2. And hey, bonus. How high would it go? Yeah, and how low? Yeah, there we go. To the next one. What's the period of this one? Well, I'm going to take 2 pi now. What's your b value here? Pi over 3. Oh, boy. Keep the 2 pi. Multiply. Flip the bottom. What cancels out? The pi's are gone. So the period will just be. Okay, and darn it, don't put the darn pi back. You canceled it out. All right, don't let it magically reappear. It's just 6 radians. Okay, it's going to take 6 radians to repeat. How would you graph that? Oh, you'll see in a second. Don't worry. I know you're asking that. Period for C, 2 pi divided by 2/3. Keep the 2 pi. Multiply it by 3/2. And what am I getting rid of here? 2's. So the period here would be 3 pi. From 0 to 3 pi, I'd see 1 sine curve. How we doing there? Because now your graphs are going to look a little different now. Questions, comments? We all right back there? Your boy all right back there, Mike? Okay. All right. What? What about it? Does it look acceptable? Can I proceed on? You sure? Okay. All right, let's go back to graphing. Without graphing, what's the frequency in the period? All right, what's the frequency in the period here? Well, let's just go first frequency. Frequency, 1/2. You and your group right now, go ahead, find the period of this graph. Two pi divided by 1/2. Yes, multiply, flip it. 2's cancel. What's the period? Actually, no 2's cancel. Sorry. Just going to be, okay. Here's what we have to change today. If the period's not 2 pi, listen up. If the period is not 2 pi, I will not graph a point every 90 degrees now. Okay, it's not going to happen. All right. Where do I determine where I actually graph these points? Here's how we do it. Have you noticed, and if you don't, you'll notice now, every time we've graphed, we divide it up into 1, 2, 3, 4 equal sections. Everyone agrees? So that's what you're going to do with the period. You're going to divide it up into 4s. All right? So to find these new key values, because like I said, if it's not 2 pi, it's not going to be every 90 now. Instead, ready? You're going to take your period and divide it by 4 every time, because you're going to divide it up into 4 equal sections. So now it's not every pi over 2, it's going to be every 4 pi divided by 4. Every pi will have a key value. And I'll show you what I mean now. So I'm always going to start at 0. Tell me something. What do you know about the cosine graph? Starts at the max. What is the max for this one? Don't tell me 1/2. Get out of here. Just 1. So it's still going to start at 1. Boom. Then it travels where? To 0. But wait, not at pi over 2. It's every pi I put a point now. So 0 at pi. Everyone see that? All right. Okay. Keep talking with me here. Starts at its max, goes to 0. What's the next one? Minimum, which is -1, but it's every pi. So where do I put the next point? Nice. 2 pi. And that's all the graph gives me. That's all I'm going to graph. Not a straight line. This is the cosine curve. Show it some respect. Actually, I don't like that, the way that looks. Do we see that now? When I have a period different than 2 pi, I will have points at different values than the pi over 2, pi, etc. All right, 1 doesn't make you great. That's for darn sure. Number 2. What is my frequency for number 2? Pi over 4. You and your partner find the period for this one. Find the period for this one. What do you guys got for me? What's the period here? Period? Should be 8? 8. Okay. So that's how long it's going to take me to make one of these graphs, is out to 8 radians. Now, we have to figure out, where am I going to put a point every time? No, not every 8. Not every 8. Not every 8. Key value every, what am I going to do with that 8? Divide it into 4, so I'm going to put a point every 2 radians now. And what's great about this is we get to set up our own x-axis. One's not given to us. So let's get a y-axis, the x-axis, and unless it states otherwise, we're going to just deal with the positive side of it. All right, we're going to deal with the positive side. So set it up right now, set up your y-axis, set up your, and I'll help you set up the x when you draw it in. They are, but this one doesn't have a pi with it. Okay, here you go. I do not want to set this up the way this graph is. Because where are my key values? Every 2. So the first point I'm going to put on the x-axis is 2. All right, I'm going to put 2 on. And it's up to you how you want to set this up on the x-axis. Just make sure all the spacing is equal. So do you want to go every 2, every 4, every 5? It's up to you. It's up to you. I'm going to go every 4. 1, 2, 3, 4. So my first point, 2. You have a key point every 2. Every 2. So what should be the next point I graph on here? 4. Yeah, every 2. 4. What's going to be the next one? 1, 2, 3, 4, 6. Yep. And then the last one, which should be the period. The last point you graph on here should be the period. There's no reason to go any further. I'm only going to graph one cycle. All right. What's the now y-axis? How high and how low is this beast going to go? 1 to -1. If you want to make that first little box 1, that's fine. If you want to go up a little bit more and down a little bit more, that's fine to spread it out. I always like my graph spread out. And that was the hard part. Here comes the easy part. Now graph sine. Now graph sine. Where's sine start, guys? Yeah. Then it goes to where? The max, which the next key value is at 2. So 1. Where's it go then? Then to the minimum. And then it ends at. That's not going to change. The only thing that changes is your scale today. That's the only thing that's going to change. Is your period's not going to be 2 pi anymore.
Yeah, it loses flavor.
Okay. I'm going to do a homework one with you too, just to make sure we're all good here. All right, so go to the assignment section, and I'm doing graph 5 with you. Graph 5. You and your partner there, go ahead. Find the frequency and period first. Find the frequency and period. Frequency, you can pick off the graph as what? 2. All right, now use that to find the period. I feel like it was different. Never mind. What's the period? Pi, okay. Oh, wait, never mind. I'm thinking of something else. All right, so how are you going to determine where you're going to plot a point? Every what here? Ooh, not every pi. That's where it's going to end, remember. That's where your graph's going to end at pi. You're going to have a value every, what am I going to have to do with that pi? Okay, so every pi over 4. Ooh, ooh. All right, ready? I'll help you do the scale. First, do the y-axis. Let's just get that over with. How high and how low is this beast going to go? 1 to -1 again. Tomorrow that'll change, but today it should just be 1 to -1. I'll throw a number out in front. So 1, can't barely read this, -1. All right, you ready for the x-axis? Be careful on the spacing. I know none of you have read the directions yet, but be careful on how far you space it out. Anybody want to read that last sentence in the directions? 2 cycles. Okay, 2 cycles. So we're going to do our first 4 and then our next 4. First point on here should be pi over 4. All right, so however I'm going to go every 2 here just to make sure I got room. So pi over 4. Now, it was easy last time because you just kept adding 2, adding 2, adding 2, no big deal. But if you keep adding pi over 4, what should be the next? Oh, boy. What should be my next value then if I go another pi over 4? Close, close. All ready? I'm going to make it easy on you. There's a 1 here, right, even though it's not showing? 1 pi over 4. Keep counting. 2 pi over 4. If you want to reduce that, go ahead. I don't care. What do you think the next one is? I did 1, I did 2. 3 pi over 4. Next one, 4 pi over 4, also known as pi. Hey, we just did 1 cycle. There's 1 cycle. Keep going, though. I need 2. So what do you think the next value is going to be? 5 pi over 4. Keep this train rolling. 6 pi over 4. Reduce it if you want. Don't care. Next up, 7 pi over 4. Next, 8 pi over 4, also known as 2 pi. You going to put another one? Nope. All right, let's finish this. Cosine graph, where are you starting it? Max. Then it goes to? Yep, finish strong here. You guys know how to plot the rest of it. I don't think I need to ask, do I? -1, 0, 1. There's 1 cycle. And then graph your second cycle. Yep. Just going to keep following the pattern again. Max, 0, min, 0. Finish at the max. Are the curves changing at all? What's the only thing that's changing now? The scale, the X scale. That's it. Only thing that's changing. All right. Okay, try to finish this up. Tomorrow we'll put an amplitude out in front. I know you're excited. A lot more time working with your